this video, we're going to start with the very beginning of that PDF for notes on lenses, which is just the basics of the two kinds of lenses. So the two kinds of lenses are convex and concave. A convex lens is one where it's narrow at the ends and thicker in the center. A concave lens is thicker at the ends and narrow in the center. Easiest way to distinguish the two. A convex lens is considered a converging lens because the light rays coming from an object, which is just the object that light is hitting, when those rays go through the lens, they will converge to form a real image, or they can converge to form a real image. For a concave lens, also called a diverging lens, when the light rays go through, they diverge, go off in different directions. I have a better visual of this in just a minute. But the idea is that convex is converging, concave is diverging. So a lens is made of a transparent material, which just means you can see through it, such as glass or plastic, has a refractive index larger than that of air. There's a different video that talks about refraction, and it goes more in depth into the index. Basic idea you need to know in this video is that it's a denser material than air. Each of the lens's two faces is part of a sphere. So if we go back to our picture, you can imagine that this side of a lens, so this side of a convex lens, could extend into a very large circle. And this side of a concave lens could also expand into a very large circle. Same thing for the other sides. Parts of a lens, these are important terms to be able to understand how to do ray diagrams later and also how to do some calculations. So the first is principal axis. So the principal axis is the axis or line that joins the centers of curvature. So in our picture here, it's the line that goes horizontally through the center of the lens. The focal point is the point at which beams of light will converge. And so if you go back to here, the focal point is marked by F. So F and F prime. Here it's just F. F is the focal point. This is where all light rays will converge if they're all parallel. The focal length is just the distance from the center of the lens to the focal point. So here, center of lens to the focal point is your focal length. So here are my better diagrams to help you understand exactly what happens with light rays. So here we have 4 different light rays that are all coming parallel as lines. When they go through this converging lens, they all bend in a way where they focus into one point. That's your focal point. For a diverging lens, for a diverging lens, you have the parallel light rays that go through, but whenever they hit the lens, they bend in a way where they go outward. So they do not converge on this side. Instead, they form a virtual converging point on the same side as the initial point. So our converging lens, this is like a magnifying glass. So if you've ever seen like videos of kids or adults that use magnifying glasses to fry ants, that's why they do, is because the light rays come through and they all meet in one location. So if you have a poor little ant sitting right here, he's going to get fried. Whereas here, they're all bending outward. And so the little ant, perfectly safe. We're going to look at drawing ray diagrams for convex or converging lenses. I highly recommend that you have the fill in the blank PDF notes in front of you so that you can then fill in the blanks and see exactly what we're about to do. So first step we need to do is talk about what a ray diagram is. A ray diagram helps us draw lines to represent light to figure out how different lenses and mirrors will create images. First step is to learn the rules for drawing these lines. This will all make a whole lot more sense once we do it. Step 1 for drawing ray diagrams is you're going to draw a line from the top of the object parallel to the lens, and you will refract or bend through the focal point. Step 2, draw a line from the top of the object through the center of the lens. And then step 3, where the lines converge or come together is where the image will be located. And you will always draw your image from the principal axis to the point of crossing. So the first one in the note says an object between the convex lens and its focal point. So here's one of our focal points. Here is the lens. So our arrow, which represents our object, is in between. Step 1 says to draw an arrow, or draw a line from the top of the object parallel to the lens. Notice I went to a center line. We bend or refract through the focal point. Light goes through a lens, so you have to draw the light going through the lens. Step 2 is to draw a line from the top of the object through the center of the lens. You should notice here, these lines are not going to come together. Because of that, we will not have a real object or a real image. Real images are formed by converging light rays. Since our light rays are not going to converge, it cannot be real. Instead, it is virtual, which means we might see it, but it cannot be projected. To find our virtual image, we'll use dotted lines to represent the virtual, and we will extend only the refraction lines. So here's our first refraction line, and then this one is, since it's a straight line through, it refracts up through the line as well. Notice we have a crossing point, we have conversion, and so our image is located there. We draw the arrow starting from the principal axis up to where it converges. This creates a virtual, upright, and magnified image. Those are your three blanks. Why would the object be virtual? Because the real light rays do not converge. Hence you can see it magnified, magnifying lens. Our second one is going to be an object held between F and 2F. So here's F, so twice that distance, our object is between. Step 1, top of the arrow parallel to the lens, and then we refract through the focal point. Step 2, top of the lens through the center. Notice now we're converging in real space. So again, here's real, and here's virtual. So it is a real object. We draw it from where our principal axis would be, down to where it converges. So this one is real. It is magnified. And now it's inverted, which just means upside down. All right, last one is further out. So top of the line, top through the focal point, and then top through the center. So our image is here. We're going to look at drawing ray diagrams for diverging lenses, also called concave lenses. So all ray diagrams for diverging lenses will be done just like this and give you exactly the same type of image. So step 1, draw a line from the top of the object parallel to the lens. The refraction or bending is through the focal point. Now because the focal point is on the virtual side, not the real side, we're going to use a dotted line. So the reason why this side is real is because light goes through a lens, not bounces off. So we're going to change it to a dotted line. Dotted lines represent virtual. And for completion's sake, draw this going out, diverging away. Step 2 is to draw it from the top of the arrow through the center of the lens. And you see, we have a crossing point. This is where our image is located. We draw it from the principal axis up to the point of crossing. So this image and all images by this lens are virtual, upright, pointing up, and reduced or smaller. Now some uses for different types of lenses. So this is for both types of lenses. One is a camera. So a camera works because you've got a lens, and as the lens is moved closer and further from the subject, you can focus it by making a larger or a smaller image. Telescopes and microscopes work the same way, where again, I know these look really complicated, but the idea is you have light going through the lenses, creating larger images. So now let's talk about the eye. So again, if you're looking at the notes, then you can just fill in the blanks as I'm saying them. The eye contains a converging lens, which produces a real image on your retina. The only reason you see things right side up is because your brain adjusts it. So it's all those electrical signals, your brain takes them and then makes them flipped upside down, basically. So you're looking at everything upside down. You can focus on objects by using muscles to change the thickness of your lens. And so you can see some muscles here and here that stretch and compress your lens. To see objects far away, you relax, and to see objects close up, you contract. But the way that we use other lenses, so external lenses, is in vision correction. So if you have hyperopia, that means you are farsighted. So farsighted, your eye is too short and everything is focusing beyond your eye. It's far from your eye, farsighted. To fix this problem, you have to put a convex lens, a converging lens, which makes it go shorter so it gets to the edge. For myopia, which is nearsighted, which majority of people are, now it's converging before your eye. So usually because your eye is slightly longer. And so you have to get a diverging lens in order to get it to reach.